We are live now. You can start.
All right. So, good morning, good afternoon, good evening to you all. And once again, I'm Mikailu Nadro. And today, I'm going to be taking the topic Archway, which is reward module and tracking module. But before I start, I'll briefly introduce DoraHacks and the PGS. So, what is DoraHacks? DoraHacks is a global hackathon organizer and one of the world's most active multi-chain and also Web3 developer platform. It creates a global hacker movement and provides crypto-native toolkits to help developers around the world. And it also funds their ideas, their videos via hackathons, bounties, grants, grant DAO, and also public good staking, which is PGS. So we have over 3,000 projects from DoraHacks community and have raised over $20 million in grants and other forms of contribution from supporters worldwide. So now, what is PGS? Public good staking, or PGS, is a Dora factory innovation wherein validator rewards get funneled back into the ecosystem rather than extracted as a typical validator commission. Right? So PGS validator uses the commission fees to sponsor grants, hackathon prizes, bounty rewards, and ecosystem funding opportunities, just like this one. So that's just a brief overview. And finally, DoraHacks bounty. So from this DoraHacks bounty, you get like the opportunity to participate in this Dora bounties as individual. If you see anyone, maybe a hacker or a researcher, you can just go into one of them and select suitable one that you can go with. It's taking a little time, but once it loads, the platform, the website is dorahacks.io/DAO bounty. Alright, great. So this is how it looks. So here are the currently active bounties that are there. You see, this hosted by Core. These are two. There are many more. There are others. The page is just loading. Sorry. What is a financial risk manager? Just and how to get certified. All this is just like an overview. There's so many bounties over here you can access. And this brings us back to our the main agenda of today. I'll be sharing. Okay, right. So the topic of today is Archway as rewards and tracking module. And here are the agenda of the day. We'll be looking into introduction. We'll look at Archway reward module and we'll be looking at the tracking module. Right. So quickly we look at the introduction. Archway is an incentivized smart contract platform that rewards developers for building on the network with baked-in incentives and rewards. So the protocol provides developers with tools to quickly build and launch scalable cross-chain dApps and receive rewards for the value of the dApps they contribute to the network. Now, overreaching the goal of the Archway is to foster like an array of diverse and sustainable applications by empowering and rewarding developers who build on the network. The mission of Archway is to ensure that entrepreneurs, developers worldwide have access to these opportunities comparable to those of their counterparts in more developed nations. So unlike early Web3 and Web2 platforms, where you see entrepreneurs and developers building on Archway, here now they receive an actual stake in growth and governance of the protocol itself, unlike the Web2 and the early Web3. and their contributions are also rewarded. Move to the next. Okay. Move to the next. Right. So Archway reward module specifications. What are their specifications? First, we look at gas tracking. So to achieve the Archway architecture desired properties, the gas tracking modules follows this design. First in the design it follows. The first is wrap the Cosmos, that's the Cosmos WebAssembly VM with an Archway gas meter to allow interception and tracking of information passed by the VM, right? The virtual machine. Then two, during the begin block, the recorded information is brought to the memory and processed to determine rewards for each of the contracts executed in the last block. And finally, the third one, rewards are calculated at a later block and the corresponding transactions with smart contracts. It comes later. Now, what are the drawbacks? The Cosmos SDK does not support post-transaction processing. This is one of the drawbacks of using this. And Archway takes into account gas limits instead of actual gas consumptions by transactions. So this is a huge drawback. And then the good news is that the Cosmos SDK could potentially have post-transaction functionalities in the future. This is an advantage to the Cosmos SDK. Then this is the architectural overview. I'll not take much time here. We are looking at the main theme. So Archway is a Cosmos SDK blockchain powered by Tendermint. Tendermint is the word. And for the networking and consensus layers, right? So the network utilizes modified Cosmos modules to manage inflation and reward system, including, okay, right, the first one, minting of the Cosmos WebAssembly. A runtime of the WebAssembly smart contracts. Basically, that's what it is for the minting. Then for the staking, basically just it manages the changes to the validators because they're actually staking to these validators there. And there's a governance section as well. It supports the one votes per token. So each individual gets to vote if you have a token. And the governance system token holders. Yeah, you need to be a holder, of course, for you to vote. And the IBC, which is the inter blockchain communication protocol that enables asset transfers across Cosmos blockchains. Like, let's say you have from Injective down to Archway, from Archway maybe to Evmos, and so on and so forth. Any of it allows this interoperability between the IBC. And in addition to using the predefined Cosmos module, Archway employs two custom modules for additional network features, which is two that we are looking at, which is the rewards module and the tracking module. So what is the rewards module for? It calculates and distributes the rewards to smart contract based on the transaction volume it brings to the network, right? And the tracking, which is very important as well, it enables tracking of this gas consumption on, on a per transaction basis. So on each particular basis, it tracks that gas transaction that happens in a particular, let's say, block creation or maybe a single transaction between, let's say, one person to another on the network. Right. So, Archway reward module, we're looking at it. We're done with the introduction now. Now we're looking at Archway reward module. Okay. So here is more of like a visual look. These are the three basic things we're looking at. The first one is gas rebates, right? Second one, inflation. The third one is premiums. Looking into all this. Now, for the gas rebates, like 50% for dApps, 50% for validators. That's how it works. Like half, 50-50. While for the inflation, we have 25 for dApps and 75 for the validators. While for premiums, we have 100% for dApps, for development rights, and 0% for validator. We'll look into this in more detail now. So we're looking at gas rebates. So unlike other smart contract platforms, Archway does not burn gas fees or distribute them entirely to the validators or miners as it normally is. So now, instead, the collected gas fees are split between the dApp developers and the validators, just like the way we looked at the previous picture. And at network launch, gas fees are divided evenly, with 50% going to dApp developers and 50% to the validators. So we're just explaining the picture that was shown earlier. Now, the network provides configurable parameters that can be adjusted over time to determine the optimal gas rebate distribution between validators and dApps. Yeah. Then from the dApp developer's perspective, a contract receives 50% rebates on all gas paid. So basically, this is just what I explained over here. Yeah. So for the inflation, the overall inflation rate on the Archway network follows the model of the Mint model in the Cosmos hub. So with the total token supply increasing between 7% and 20% annually. So this is inflation, depending on the rate of tokens that are actively staked on the network, inflationary. Now, Archway protocol then shares a portion of these total inflation rewards directly with dApps, right? At Genesis, 25% of the inflation rewards goes to dApp developers and 75% goes to the validators, just like how we explained again. Now, smart contract fees. The smart contract platforms today charge network fees based on the amount of computational processing, right? Then required on chain transactions. While this method is measured is sorry, while this method of measurement works for the underlying economics of the network, it does not support use cases where a developer has, let's say, to cover additional costs such as distributed storage, access off-chain processing, and also external data sources or other premium features such as audited and insured contracts. So it doesn't consider all these ones mentioned. Now, with Archway developers of dApps, with Archway, developers of dApps can define custom fees for interacting with their smart contracts, also known as take rate. That's what it's called. Now, this fee provides developers with a flexible option to charge different fee levels that are based on their specific use case and operational needs. Now, unlike just the way the other smart contract platforms of today operate, where they don't consider these flexibility, right, for you to integrate your kind of like your operational needs. Because yeah, when off-chain processing is not considered, external data sources and other premium features such as audited and insured contracts, you see, you incur extra charges on your own end and it's not being considered. But here it's being considered in the Archway, which is great. Now the fee is configurable and the dApp owner can adjust it at any time, which is good. And even after the contract has been deployed, that's one of the beauty of it. It can be adjusted even after it has been deployed, which is unlike the regular smart contract platforms we've seen. So the next, Archway economics. Very interesting. Now, the Archway dApps can earn a portion of transaction fees and inflationary rewards in exchange for their contributions to the network. Now, this model is similar to how validators are rewarded for operating nodes in a typical proof of stake chain. Now, Archway seeks to provide three potential funding sources. Now, you explore some of them here. So some of the business models only made possible through Archway customizable economics, right? And here they are listed. First, you can see enable development. Second one, support a DAO, subsidize gas fees, which we explained earlier, rebuilding gig economics, reward NFT creators, very important, reduce DEX fees, this also very important. There's been a lot of complaints about DEX fees these days, and offer free trials. This is very important. If you want adoption, we offer free trials. Then incentivize voting for the governance, of course. Then since it's running on a proof of stake. And finally, allow non-dilutive liquidity mining. Very important. So look at the examples use of the we'll look at the use cases examples. So the first one is for governance rewards. Now, what is it? The recent trend has dApps issuing governance tokens to incentivize and bootstrap early communities. Yes, they do that. This token distribution has proven to be very successful in a number of cases, despite the dApp not having any clear mechanism for value capture for fees or revenue. Some of these tokens merely grant voting rights, but have still been the subject of intense growth due to the speculation of the future utility of this dApp. Yeah, you see a lot of people huddling and they are rushing into new, especially new projects that are promising all these that maybe some form of incentivized mechanism. Maybe if you interact with their dApp or something, you see a lot of inflow, a lot of people testing, maybe testing their testnet, staking on their platform, and other things. Seeing this trend going on. And now, in the Archway model, dApp developers can redistribute their share of the network rewards. This is unique and directly to their governance token holders, right? So subject to local security laws also take note. And while individual dApps on other networks such as SushiSwap have implemented similar functionality, the Archway protocol makes it possible to implement and manage governance rewards at the protocol level, which we do not see in most cases. This is unique and it's kind of it's reasonable if you look at it. So why should I uh, take part in your dApp or your project or your network if all these things are not going to be offered? Feel like we really do a lot. And support the core development team also is some form of incentivized way or mechanism to support the core development team, right? So rewards offered by Archway can help developers bootstrap new projects without having to dedicate excessive time and focus on fundraising. Instead of them looking or checking other places for funding, you can just activate this funding directly from Archway itself. This is this is huge, and you don't have to go somewhere else. Just get everything in one place. It's like an all-in-one kind of thing. And the second one, okay, also here we see the model introduced by Archway can counter some of these early financial pressures by allocating dApp rewards directly to the core development teams, and also subsidize gas payments. This is also important. So the gas payment remains one of the critical barriers to delivering a simple, intuitive user experience for dApps. As I mentioned earlier, most people they keep complaining about the high gas fees when they're interacting with all these dApps, decentralized applications, or DEXs. So what does Archway have to do with this? Now, here's what they are saying. Archway supports gasless transactions through the use of pool accounts, and the dApp can pull funds from a common pool to sponsor gas payments and completely abstract away that complexity and friction for its end users. That's like you and I. This is huge. And also, to fund the full account balance, a developer can use the fees and rewards generated by the dApp. In effect, the dApp gets a 50% discount on each transaction from gas rebates along with the inflation rewards and the contract fees that are potentially available as a bonus. Wow, this huge. You would not find this anywhere. I don't think there's any kind of stuff like this currently. So they have a way of subsidizing their gas payments and they made it flexible in a way that you can access the gas fee, right? And getting the discount at about 50% discount on each transaction from gas rebates. This is huge. Okay, let's look at the next one. Boost. It's also for boosting liquidity mining programs. This is another use case for Archway. So DeFi projects can use the funds and from Archway to boost liquidity mining rewards, fulfilling a vital strategy for attracting new users and also encouraging active participants. Of course, when you boost, you show them they can have access to like liquidity or boost liquidity mining rewards. See, a lot of people would want to adopt this and would want to join this or even external projects, maybe startups and looking for a new home. I think Archway is a good way to start because you can have access to some of these mouth-watering rewards like boost liquidity mining rewards and other things. And also an example here, a decentralized exchange can be designed to distribute rewards on top of the fees already paid and also the LP liquidity provider. Now, fund a decentralized autonomous organization, a DAO. Now, rewards generated by DAO can be contributed to a community-owned DAO. This is focused on coordinating and funding critical work for its ecosystem. Now, these rewards can be continuously deposited to a DAO treasury that allows members to collectively manage and deploy assets based on the specific needs of the project. So, like the whole DAO community can have access to this and can easily how what they can easily have access to these funds and even as they are doing like let's say internal development, they could have access to this and also create theirs and have a way of incentivizing it. It's also very important. Go to next. Okay, so reduce DEX fee. This has been a problem. Now, on networks such as Ethereum, DEX users enjoy two sets of fees, a network fee and a swap fee. These two. Now, the network fee incentivizes the miners to operate nodes, and the swap fee incentivizes the liquidity providers as the LP providers, right? That's how basically it works on the Ethereum network. So by deploying to Archway, if you are deploying to Archway, here's what you get. DEXs could be constructed to effectively eliminate one of the network or swap fees. So you can take one out. Instead, the DEX protocol could redistribute the end gas rebates back to the LPs for providing liquidity. So none is missing. So let's say you take this back. So from the rebates, it still goes back to the LP provider. So none is actually left out. This is a huge um, type of or kind of mechanism that's going on here. Now we look at governance. Very important. This is running on a proof of stake. So governance is a process in which Archway network participants and the token holders can influence the future direction of the protocol through proposals and on-chain voting. So if you are a holder, you get to vote on a proposal. You can vote for or against this. So this is usually only accessible for governance token holders. Let's say you have Archway token and you see a proposal and you feel it's not a good one for the Archway ecosystem, you could vote against and the fees are just little. Think over less than a cent or small. All right. So now contract metadata. Now, contract metadata provides information to the Archway network about the contract owner and the address to which rewards should be sent. Now we're considering, since we are still on the rewards module, right? Um, Contract metadata is a huge part. There are basically three basic functions: the contract address, the address of the deployed contract, the owner of the address, of course. These are the three basic parameters I mean. And the address of the owner and the contract owner. These fields can be both an account or a contract address. And the final one is the rewards address, the account address that will receive the contract reward, right? Then there will be a withdrawal function. And this is the setting. Here is the code block. This is how you write it down. You fill in the right contract and basically. So what about updating the contract metadata? Now, the owner address is the only address that can update the metadata of the contract. Of course, not anybody just come up and say he wants to edit the contract metadata. This can only be done by the owner address, right? So this could either be an account or a smart contract address. Updates are completed by using the message. This is the function is the message set contract metadata transaction. Now, if the owner address is a smart contract, updates to the metadata can only be performed by using a WebAssembly binding. So now, reward storage. The rewards owed to a specific contract are stored in a separate record on the blockchain. To receive these rewards, a withdrawal operation must be executed. Developers can also track these rewards by using this what they call the rewards record object. That's what you use. That's the only thing you can use is when those rewards are being owed and you want to have like withdraw these rewards back. You use the withdrawal operation, and for it to be executed, you need to use the rewards record object. Right. So that's all about now we're looking at the tracking module. We're done with the rewards module. Now we're into the tracking module. All right, we go straight to the code. The reward record object is used to track the rewards that have been calculated for specific reward addresses. Right, this is basically about tracking this reward now. So this is an example. You have Archway, queue, rewards, right? Node, then you have mainnet and testnet. Very important. Testnet is for you to test it out. When you test it out and you feel it's good to go, no bugs, nothing, you can go on to the mainnet. And similarly, the way it works there on the testnet is the way it works on the mainnet. So this is very important to note. So example response, right? This is an example response. You have your ID, which is one, the rewards address, you have your denom in ARC, and this is the amount. Total amount is about 10,000 here. This is just an example by the way. Calculating height of 100, calculated time in seconds, right? Then in nanos in 0. And you put this code block. This is just an example of uh, a, a reward that is being tracked. Tracking reward module. Right. Another example. Request and response continue. The continuation of what we're reading earlier. Now, where you are able to see the following fields, the ID. Let me go back a little. This particular ID here, that's showing one. Each reward record has a unique ID, and this can be used to only withdraw certain reward records. So it's very important to take note that these IDs are unique. And then reward addresses, the account address that will receive the reward. I think this was mentioned in the reward model. And tokens are sent to this reward. after executing a withdrawal function. If not set, the contract will not receive this reward, of course. Then this denom over here in the code block, the second one is what it's for. The token type, that's what it is. The monetization, that's why it's called denom in short. And UARC is a default EEARC, yeah, right? Then the calculated rewards amount is for this amount, this one, 10,000. Maybe that's the amount of ARC token that the person is receiving or the reward address is getting. And then the calculated height, the block height of the rewards when the rewards were calculated. And then the calculated time, the block time when the rewards were calculated. And then the withdrawing reward. This is all clear now. Now, withdrawing reward. Now, after rewards are calculated, the next step is a withdrawal operation must be executed before they are sent to the rewards address, right? So now, the withdrawal operation is completed by using the function MSG, that's like message withdraw rewards. Message is a message, MSG. So only the address set in the reward address can claim this reward. So this is an example under here in this code block. You can use the following command as reference to how rewards can be withdrawn. Now, from what we did before, if we read this, right, and the request has been sent for the receiving address, the rewards address, I mean, to receive the reward. But for him to receive the reward, he has to follow this message, which is the Archway transactions, this. You put in your time, the reward, and yeah. And of course, only the reward address can claim this reward because earlier you can see it was stated in the code. Yeah, the reward address is clearly written here. So for the withdrawals, only the reward address, of course, can claim using this code message. So sending this message, sending a message for receiving that reward that was sent. So this is the final message you have to send. This message withdraw. See it over here. Right. Now, request and response. Where the following flags can be set. Record limit is the maximum number of reward records that can be withdrawn. If the limit is 0, then the default limit is used in the withdrawal as well. Now, for the record IDs, this is very important. If you want to withdraw specific reward records, an array of those IDs can be included, right? Let's say for specific rewards. And for the reward address, the reward address that has been set in the contract metadata, and we have the node. Node is just the endpoint of the node to be connected to, and the chain ID, of course, Archway chain ID. That is the contract. That is the contract that is on, which is the chain ID. Then the response, if the withdraw rewards operation is successful, the response will show the number of rewards records processed and also the total number or the total amount of rewards that has been transferred to the rewards address. So this is the response the person would get. The total rewards that he has received, he or she has received in her own end over there. All right. So now querying outstanding rewards. What if you have outstanding rewards? Okay. So now querying outstanding rewards. To track what rewards have not been withdrawn. Let's say you have some rewards that is not withdrawn, and send the rewards address, Right? You want to send these rewards that have not been claimed by you. So you use this command below. This is the command Archway queue rewards outstanding rewards. You write it down like this, and a dollar. You put in your reward address, these curly brackets, and you have your node, HTTPS, of course, the RPC, mainnet, Archway.io 443, Archway chain ID. This chain ID is the contract on which we are working on, of course. And the output JSON. Okay. So Archway network architecture overview. The overview. The Archway network is built on the Cosmos XDK, Tendermint, IBC, and also Cosmos assembly language, WebAssembly. So the network starts as a proof of stake network with modified minting, Cosmos WebAssembly, distribution, staking, group, and governance, Cosmos native modules that manage the Archway inflation and value the capture system. So from the architecture now, first you have your smart contracts. So what languages do we use in writing the smart contracts? Here is a unique thing about it, the smart contracts on Archway. Now, Archway protocol is what it uses, Cosmos WebAssembly. It uses WebAssembly as well, uses Rust language, and also Golang, right, for the backend. And over 40 high-level programming languages support the WebAssembly, which is very, very excellent. It can help with the onboarding of like people from Web 2 that are interested in joining the Web 3 or joining Archway. They can easily integrate. Then we have the C and the C++. I also have Python, Golang, Rust, Java, PHP. So all these languages also support uh, the smart contracts on Archway. So yeah, if you know any of these languages, you can easily uh, integrate into or start developing on the Archway. You can start developing Archway smart contracts. Okay, right. So now dApp versus app chain. Now, while the ethos of Cosmos is to allow the creation of self-sovereign chains, the the whole idea of the IBC. Now, in many cases, it may make sense for a project to first deploy as a dApp. There is a lot of overhead involved in launching and maintaining a standalone chain. It's a lot because a standalone chain is not a little stuff. You're doing a whole lot. It's a whole network you're creating. Now, while the Cosmos SDK simplifies much of the technical effort, it still remains technical, even though they help with a lot. And to build your own self-sovereign app chain, a developer still needs to attract and sufficiently incentivize a strong community of validators to run the network. Basically, that's how chains work. You just need to get this, and which can be a daunting endeavor because for early projects, this is not easy for you to have, let's say, to 50 validators, active validators running. And all these things require funds and incentive. You have to incentivize them as well. Now, consider the following trade offs between building your core logic as dApp versus building your logic as an independent chain. So, we are taking a dApp kind of like dApp versus chain. So, Cosmos chain now, speed development is not fast. So, you see, it's red, smart contracts are fast. Is um, this for dApp against chain. So ease development, no, chain is not. While smart contracts are very fast, you can easily develop them. Now complexity logic, we give that to the two of them. They are both have complex logic, and maintenance overhead is not the case for the Cosmos chain, of course, while it's the case for smart contracts. And the level of customization is very high on Cosmos chain because you know it's a network. You customize a lot of things. You have that in it. You have DEXs in it. You have like a whole lot of things, even NFT projects you want to integrate in it. So lots of customization. But that's not the case for smart contracts. Smart contracts are usually specialized for a particular purpose. Let's say a DEX, a DApp, or whatever it is you want to create. Then strict resource control. It's not the case for Cosmos, while it's the case for smart contracts. As we mentioned, it's not an easy feat like to attract and sufficiently incentivize a strong community. You don't just get that in a chain. You need a lot of investors, a substantial amount at least. Now, for the native chain feature, yeah, we have that on Cosmos. It's not the case for the smart contract. And scalability, they are both scalable, of course. All right. So migrating dApps to self-sovereign chains. Let's say you are testing around and you got to maybe build a dApp on the Cosmos ecosystem or the Archway, right? And now you want to launch your own self-sovereign chain. This is possible now. So some projects may find that the starting to build their own solution as a dApp rather than a self-sovereign app chain better suits their needs. However, the requirements of software projects inevitably evolve over time, and Archway is built around the Cosmos vision of the self-sovereign chains that provide proven migration support, right? Archway provides a simple way to deploy contracts to the Cosmos ecosystem. For many developers, continuing to run those contracts on an established chain like Archway is sufficient for them, as long as it's just a dApp. But however, for those dApps that hit a certain level of traction and require a network that can be tailored to their specific requirements, which is the self-sovereign chain now, maybe that's what they require. It makes sense to run their own dedicated chain. The migration is straightforward because the Cosmos WebAssembly contracts are portable across chains, and the Ignite of the CLI allows developers to spin up and configure their own independent chain easily on the Cosmos ecosystem in a matter of minutes. In this sense, Archway can be seen as a launchpad into Cosmos because it helps all these things, makes all these things possible for the SMO. So kind of we could call it launchpad into the Cosmos with the flexibility for developers to easily migrate to a standalone chain if and when a dApp is ready. Right? So this is huge. When let's say your project is now kind of, will I say, popular, you're trading, you feel you guys can run your own standalone chain or self-sovereign chain. Could easily do that using the Archway, using CLI to do that. In a matter of minutes, you can launch. You won't have that much issue because your dApp is already launched on the Cosmos ecosystem, right? You are familiar with all the do's and the don'ts, the technical parts, so you can easily launch your own self-sovereign chain without having any drawback, much drawbacks. Now, decentralized governance. Archway governance is a process in which the network participants and token holders can influence the future direction of the protocol through proposals, on-chain voting. Proposals and on-chain voting, these are two different things actually. Through proposals and on-chain voting. In addition to fees and staking, Archway's native token is used for governance as well. This helps maintain and support the Archway decentralized community while ensuring fair and transparent participation. Okay, get this now. All holders of the native token can propose changes to the Archway protocol, and all stakers of the native token can vote on active proposals. So if you are staking, if there are some proposals that are there and you feel it's not going to be good for the Archway ecosystem, you could vote against. Or if you feel it's good, you could vote for. if you're an active staker. And then doesn't keep only stakers in. If you're a holder, it also allows you, uh, yeah, native token can propose changes to the app. Yeah, if you are a holder, a native token holder, you can also propose changes to the Archway protocol, while it's the stakers that would vote on the active proposals. All right. So proposals can reach a consensus threshold are adopted. When adopted, rather, proposals can range from specific features, upgrades, to even changing the governance system itself. This can also be done. That's how powerful it is. That's why it's called governance, right? It's the people. You want that. People on Archway, they vote, they bring this proposal, and no one is actually left behind because the stakers are there, the holders are there, they can just draft a proposal. Maybe you have a community of people of let's say Archway enthusiasts. You could write a proposal and submit. If it's given a go ahead, then maybe you could have a better um, ecosystem. Okay, and here are some of the references that were used for the write up, and thank you very much. All right, so think we'll take questions if there are any questions in the comment box.